Hi everyone, in today's class we are going to talk about three new concepts: variables, uncertainty in routing, and temporary batching. So let's see what's each one of them. So variables are used when we want to calculate things or statistics in ProModel that ProModel does not calculate for us automatically. So as you know, when we run the ProModel models, a report is automatically generated and a lot of statistics are reported to us in that result. However, we may be interested to report a couple of statistics that are not automatically calculated. To be able to do those, to be able to calculate those, we use variables. Uncertainty in routing happens when a part finishes operations on one machine. However, depending on the result of that operations or some conditions that may hold, the part may end up at different destinations. For example, a part finishes the inspection operation, and based on the result of the inspection, a part may be scrapped, a part may need to go back for some rework, or the part may be 100% okay and can continue to the next operation. We will also learn how to capture those scenarios in a ProModel simulation. And finally, we will learn temporary batching, and that's when we need to basically process a group of entities together, and these entities will be similar. However, we have to process them together and then they go through the rest of the process one by one. So for example, parts come to an operation, they go through each one of the operations one by one, and then we get to the, let's say, oven, and these parts need to get processed on the oven. And however, the processing at the oven is not done on parts one by one. We have to have, for example, a batch of 10 parts and process them all together on the oven. In that scenario, we are going to, as we say it in the ProModel, batch a group of 10 entities that are similar together and process them together, and then after this operation we let them again go through the rest of the process one by one. We are going to learn how to implement each one of these techniques in the simulation, and then when I get to each one of them, obviously I will explain more on what they mean, and I provide examples so that you can get a better understanding of these concepts. We are going to start with variables. So as I said, variables are used to calculate some statistics that are not calculated for us automatically by ProModel. For example, when we run a simulation, it tells us how many entities have left the system. That's total exit, right? The entities that have been processed and have left the system. However, we may be interested also in calculating work in progress, WIP. So work in process, as you know, represents the number of parts that are somewhere in the system. Either they are waiting in the line to get processed or they are being processed, and we are interested to know the value of work in process for basically any system, either manufacturing or service industry. For manufacturing industry, we are interested to know the value of this variable because these parts that are sitting somewhere in the manufacturing process, either waiting or being processed, they are all potential revenue. We don't want a high value of work in process, so we want to be able to track this statistic or this variable, so that if the number is going up in a manufacturing process, then that's an alarm that, okay, something is going on, we have to take some actions. And in the service industry, that's the same too. So in the service industry, for example, if you're modeling a bank, and work in process, which is number of customers or entities that are already in the bank, either waiting in the line or being processed somewhere, if the number goes up, that means a lot of people are waiting or just somewhere in the bank waiting to get processed, and that's not a good statistics that we want to have, because that obviously affects customer service. So we are usually interested in monitoring the value of work in process, and this is, as I said, is not something that ProModel automatically calculates for us. So we want to learn how we can use the concept of variables to calculate the statistics that we are interested to report. So now let's see how we are going to do that. So this is the first model that we are going to develop. So please create a folder for week 5, and inside that folder, create a new model, a blank model, and name the model as Southern California foraging dash variables. Okay, create a folder for week 5. Inside that folder, create a new model and save your model, name your model as Southern California foraging dash variables. Okay. And so what is happening here? So here we have a receiving dock. Foragings, which are our entities, go to the receiving dock. And then from there, they go to the miller to get processed. The processing time on the miller is normal with average 10 and standard deviation 1. From there, they go to the grinder. Processing time on the grinder is uniform with average 8 and half bit size of 2. And these times, all of them are in minutes. And then finally, from there, they go to finished part store, and from there, they are just shipped to the customers. So the receiving dock has capacity of infinity. Everything else has capacity of 1. What we know about the foraging, our entity, is that we receive foragings in batches of 5 every 60 minutes on average, exponentially distributed. Okay. And so developing this model is very, very simple. You guys can just quickly do that, right? We know we just have 4 simple locations. We have 1 entity, 1 arrival, and the processes is very simple. Okay, so you can easily model this. What we want to do in this model is to learn how we can define variables to calculate work in process. Okay, so that's what we are going to learn in this model. So what I want from you guys is to very, very quickly, so that we don't lose them. Very quickly, please create 4 locations for receiving dock, miller, grinder, and finished part stores. All the locations have capacity of 1 except receiving dock. We have 1 entity foraging, and you know the information related to the arrival of foraging. So everyone, please very, very quickly put this model together. You can also finish the processing easily. And then I tell you how to add the variable. Okay? Catherine, do you want to share your screen? Okay. So we have 4 locations, 1 for receiving dock, miller, grinder, and finished part store. I said all the locations have capacity of 1 except the receiving dock. Okay? Everyone is okay so far?
Yep, so far so good.
Okay. Let's go to the entities. Okay. We have 1 entity, we call it foraging. Let's go to the arrival. We receive the foragings in batches of 5 every 60 minutes, exponentially distributed. So quantity each obviously shows how many entities we receive at a time. So since we receive the entities in batches of 5, quantity each is 5. First time 0, meaning that we start receiving the entities potentially from the start of the simulation. Occurrence is infinity because I didn't give you any limit on how many entities you have to come to the system. So the entities can come to the system for as long as we run the simulation. Occurrence is infinity, and then frequency is E 60 minutes because the inter-arrival time is 60 minutes, exponentially distributed. Is there anyone who had difficulty with setting up the arrival? Okay. So make sure, guys, you all know how to set up this part. This is one part that I have no mercy on when in the exam and homework, okay? You all have to get this part correctly. And then let's go to processing. Okay, so foragings go from receiving dock to miller, from miller to, next line, from miller to grinder. And at miller, the processing time is normal distribution, average 10 standard deviation 1. And then from miller to finished part store, uniform 8 minutes average, and half bit size is 2. And then from finished part store to exit. Okay. Everyone is okay so far?
Yes, Professor.
Okay. Daniela, everyone is good?
Yes, I'm good.
Yes, Professor, thank you.
Okay. Can you stop sharing? Catherine, thank you very much. Can you stop sharing? Okay. Now what we want to do is to learn how to incorporate the variables. Okay. So okay, so let's actually go back here and let's run the model for 100 hours, one replication and just 100 hours. So let's run that. I also have move time, move logic, 1 minute between all these operations. Can you quickly add that too? It's not critical, but just so we get similar numbers. And then run it for 100 hours. No.
That looks like what we got, Professor. Thank you.
Okay.
Yeah, I got the same.
Okay, so let's go back here. So what we want to do is that we want to calculate work in process. Okay, so as you can see here in the results, we have total exits and a bunch of things if we go to the table summary, but we don't have work in process for the entities that are, for the forgings that are somewhere being processed in the system. So we want to learn how to add that. So for those, we can add variables to the model. So let's go to the variables icon here. Do you see it? On the menu, there is variables. If you click on that, then you can here define variables. So I'm going to define one. I'm going to call it work in process. Okay. Everyone is okay? Go to the variables and just type the name of your variable. This time we want to calculate work in process. So just type work in process and done.
Professor?
Yeah.
I'm using the old version. Where can I find the variable?
Go to the build menu. You will see variables.
I got it. Thank you.
And here on the type, you see if you click on that, you have the either integer or real. So here, if you want to calculate work in process, it's obviously an integer number because the work in process goes up when one part is added to the process and goes down by one when one part leaves the system. So work in process is going to be an integer, okay? So because of that, we define it as integer, but sometimes we will define some variables that that are not integer, they are real numbers. So for those, we will pick real, okay? So make sure it's integer and just give it the work in process name, and that's it. So make sure to save your model, guys, as we go forward. Let's go back to the processing. And now here, I want to change the value of this variable. So when we define this variable at the very, very, very start, the value of this variable is 0. Okay. So now I want to change the value of this variable. So let me ask you this question. If you were going to find the work in process, meaning the number of parts that are somewhere in your process in a real world, don't forget about simulation. How would you do that? Like you have a notebook and a pencil. That's all you have. How would you, and this is the start of the day. There's no part in your system, in your manufacturing process, and you want to calculate your work in process during the day. So how would you do that?
You take all the parts that enter the system and all the parts that exit the system, and you'd subtract the two numbers.
But that doesn't tell you the work in process during the day. That's not the right. So let's say I want to be able to monitor my working process during the day. I want to see gradually it's going up and then it's going down, or it has fluctuations. So I want to be able to monitor my working process over time. You want to know your working process at any point of time of the day. How do you do that?
Count how many products are going through the process from receiving to milling, and then subtract them from grinder to finished part store?
So basically I can just have an intern stand by the entrance. Every time new parts comes to the system, this in turn is going to increase the working process variable by 1 because this part is coming to the system and is going to be processed in the system, right? Every time a part comes to the system, this variable working process is going to be increased by 1. And every time a part is done and is leaving the system, this variable working process is going to go down by 1. Is that correct? So every time a part comes to the system, it's going to get processed somewhere, right? Either wait in a queue or get processed. So I'm going to increase the working process by 1. So that means a part has come to the system. So let's assume initially there is no part in the system. A part comes in. Okay, working process becomes 1. The part is being processed somewhere. A new part comes in. Working process becomes 2. The part goes to get processed as well. A new part comes in. The working process is 3. A new part comes in. The working process is 4. And now let's assume before the 5th part comes in, one of the parts that were being processed here is done and is leaving the system, right? So now what is the value of working process?
4.
It was 4.
Row 3.
It was 4 when all these 4 came in. But as I said, just at this point, before the 5th part comes in, one of these parts that is already in the system, one of these 4 parts is being processed, is done and is leaving the system. So the value of working process then goes from 4 to 3, right? Because one part just left the system, right? And now let's assume the 5th part comes in. So the value of working process goes back to 4 again. Let's assume the 6th part comes in. The value of working process goes to 6. Let's assume before the 7th part comes in, one part is again done and is leaving the system. So the value of working process goes from 6 to 5. Let's assume before the 7th part comes in, another part is done and is leaving the system. So the value of working process goes from 5 to 4. Let's assume another part leaves the system. The value of working process goes from 4 to 3. Okay? And now let's assume another part's coming. So it goes to 4, back to 4 again. Okay? So this way, we can calculate, we can monitor the value of working process in the system at any point of time. And if we see that gradually during the day, value of working process, yes, goes up and down, but it has an increasing trend. So that means something is wrong with the process. The parts are not leaving the system as fast as they are coming to the system. Okay? Does the logic of calculating working process make sense?
Yes, Professor.
Okay. So now in the simulation, we are going to do the exact same thing. So when a part comes to the system, as soon as they get to the receiving dock, I want to increase the value of this working process variable by 1. So how I'm going to do it? We are going to write it as working process equals to working process plus 1. What does that mean? It means get the value of working process, whatever it is, which is initially 0, increase it by 1 and save it in the same variable. Okay, so that's what this means. And you can also see it here in the operation. So working process equals to working process plus 1. That means increase the value of variable working process by 1 and save it in the same variable. So every time a new entity comes to the system and gets to the receiving dock, simulation performs this first line of the code for us. Okay. Is that clear, everyone? So far?
Yes.
Yes.
Yeah.
Okay. Now, I increase the working process variable by 1 every time a new part comes to the system. However, I also have to decrease it by 1 every time a part leaves the system. So I go to the last line after finished part store, when they are at finished part store and they want to go to the exit, I say, okay, I want to decrease the working process by 1. So I say working process equals to working process minus 1. This means the value of working process is going to be decreased by 1 and it's going to be saved in the same variable. Okay? So that way, the variable work in process is going to show the number of parts that are in the system. Every time a new part comes to the system, it's going to be increased by 1. Every time a new part leaves the system, it's going to be decreased by 1. So if we plot the value of this variable over time, it shows the number of parts that are in the system at any point of time. Does that make sense?
Yeah. Yes, Professor.
Okay. Make sure to save your model, guys. So this variable that we built here is called global variable. And why it's called global variable? Because we can define it anywhere in this. I mean, when we define it, we can change it anywhere in the simulation. I can change it in the first line. I can change it in any of the lines here, in the operation logic, in the move logic. I can change it even in the arrival if I need to learn how to do that and so forth. So these are global variables, meaning that you define it once here, and then you can change it and update it anywhere in the simulation. We have one other option for the variables. We call it local variables. The local variables are defined and they can be changed only at one part. So, for example, here I defined a variable here in the operation of the first line, and I can change it only here. The local variables are not recognized anywhere else in the simulation. Okay, we will get to those later and I will explain them, but we will go through examples related to local variables. But what I want you guys to know is that these variables that we define using this menu and can be changed anywhere in the simulation are basically global variables. Okay, so that's that. And then what I want you guys to do is to define a variable that is going to count total number of parts that have been processed and are leaving the system in this simulation. So if I look at the simulation results, that's basically total exit, right? Total exit shows the total number of parts that have been processed and have left the system, right? And I know the simulation automatically calculates that and reports that for us. But just for the sake of learning, I want us to define a variable, and we can call it quantity. Here, let's go back to the variable menu. So let's say here I'm going to call it quantity process, or anything you want. Okay. So I'm going to call it quantity process. And again, this is an integer variable because I want this variable to show number of parts that have finished processing and have left the system. So obviously this is integer. And I want you guys to think about it and see how I should, or where I should change the value of this variable such that it counts number of parts that have been processed and have left the system. That's you guys are going to do that, and I'll call names and ask this question. Okay,
Professor?
Yeah.
When I went back to the variables, I couldn't find the first one I have created, which is the WIP. And then when I tried to create it again, it said that it was duplicated. Is it normal that I can't see it again?
No, you should be able to see it. Can you share your screen?
The problem is that I'm working in another computer. It's not on my laptop. Just a second. Let me see.
No, you should be able to see it. The fact that it does tell you that it's already there, it means.
So even if I scroll down, I can't see it. So I thought maybe that's because of the old version. I'm gonna try to.
Old version works perfectly fine.
Let me try. Let me try to create it again, and I'll see.
Okay.
So Professor, you want us to put the quantity processed into one of the operations in processing?
I want you guys to, okay, what I want you guys is to calculate how many parts have been processed and have left the system. Okay? That's what I want you to calculate. How do you calculate that? Using variables. So we defined a variable, we called it quantity process. Okay, so what I want you guys to do is to find out where you have to change the value of this variable or update it or increase it or decrease it or whatever, so that at any point when you stop the simulation, that variable is going to tell you how many parts have been processed and have left the system. Is that clear?
Should it be at the
Yeah.
finished parse store?
I want everyone to finish first, and I ask you guys to answer.
Okay.
Just 1 minute.
Okay, so what I did was first I went to variables. I made a variable total. Then in my processes, I went to the last operation here, and I have total equals total plus 1. Since we're starting at 0, everyone that goes out from the finished part storage to the exit will be counted.
Okay,
And that's how I did it.
That's correct. So here, if you had no simulation in the real world, you are in this process and someone asks you, tell me how many parts are processed and are leaving the system each day. So what would you do? You will stand by the exit or finish part store. Every time a part is done and is leaving the system, you're going to increase your counter by 1. At the end of the day, the value of the counter tells you how many parts have been finished and have left the store in that specific day, okay? And that's exactly what we did here in the simulation. We created a new variable, we called it total, and here at the very last line, when we leave the finished part store, we are going to increase the value of this variable by 1. The initial value of this variable is 0. So every time an entity passes through this last line of the simulation, the simulation is going to increase this variable by 1. Okay, so when we stop the simulation, the value of this variable shows how many entities have left the system by that time, that here. And again, what I told you in, I think previous session about something else was that here, I know the value of my variable is quantity process. So as soon as I type Q, this opens up and I can see the variable name. So I always pick from here instead of typing, because there is always the chance of typo and you may get just nonsense errors which are unnecessary. So always pick from this window, and that's fine. Okay, so that's that. So save your model. And just one more thing, guys. Here, remember I showed you we can say work in process equals to work in process plus 1. There's another way that you can write this code. Is called increase INC work in process. Okay, so when I say increase work in process, it's going to increase the value of variable work in process by 1. So you can write any of these. So for example, if I could just say this, and that's correct. I could, when the entities come to the system, I could just write increase work in process, and that means work in process equals to work in process plus 1.
Professor, so for quantity process plus 1, it can be the same thing, right? Increase quantity process.
Exactly.
Professor, can you explain again why did you add the quantity processed equal quantity process plus 1?
Because I want to calculate number of parts that have finished processing and they're leaving the system. Okay, so at the very last line, when an entity is done and is going to the exit, I'm going to increase the value of this variable quantity process by 1. So every time an entity is going through this line, I'm going to increase the value of quantity process by 1 and save it in the same variable. So if I run the simulation for 100 hours, at the end of 100 hours, the value of this variable shows me how many parts have finished processing and have left the system. Okay. So yeah, so here instead of quantity process equals to quantity process plus 1, I could just say INC increase quantity process. That would be correct. And then here also for the decrease, we can do similar things. So when I say W work in process equals to work in process minus 1, I can just say decrease, DEC, work in process. And what this line does for me is that is going to decrease work in process variable by 1. So I can just write work in process equals to work in process minus 1, or I can just say decrease work in process. Okay, and any one of them is correct. But just want you guys to know both of them.
Okay. And these variables, they can be defined either in operation or in move logic?
Yeah, anywhere. They
Okay.
can be modified. They are defined here in the variable menu. But they
Yeah, no, I understand that. It's just in the process section, I was just unclear whether they should put them under operation or move logic, since we saw examples of both.
Yeah. So you can change the value of these variables anywhere in the operation or move logic, depending on what you want to do and where is the right place. You can change them anywhere that makes sense for you for that model.
How will we know what will be the right place?
We'll get to examples and you will see how that works.
Okay.
And then if we go to the table, do you see variable summary here at the bottom? Variable summary. Do you have that, guys?
Yeah, I see it.
If you click.
Wow.
No? If you go to the table, variable summary. Okay? If you click on that, then this window opens and you can see the variables that have been calculated for you in the model. So what is important here, very, very important, is that which one of these columns you have to report, which one of these columns makes sense, okay? So for work in process, the very first one, first of all, everyone can see this window in your model, right?
Yes.
Okay. For work in process, the very first row, average value shows average of work in process during the simulation run. So for 100 hours that we ran the simulation, on average, 13 parts were somewhere in the system. Maximum value is 38. At some point, there has been 38 parts in the system. And minimum is 0. At some point there has been no part in the system. Obviously, like when we started simulation, that was at the very least there was one instance when there was no part in the system. Okay.
I'm sleepy. Would there be sleepy?
Sahar, make yourself mute. And then here, so the question that I have from you is that which one of these columns makes sense to report?
Professor, I would think maximum value, because if you're, well, that's money tied up in the system. And it also might point to how big your bottleneck is in there.
But well, how do you know? Maybe that has happened just for a short amount of time and then here.
Average time per change? I don't know if that also means average time in the system.
No.
Yeah, what does average time per change mean, Professor?
So the average time per change means like, okay, so the total change means 996 times this variable has changed in the system. Remember, this variable is going to change every time a new part comes to the system and every time a part leaves the system, okay? So this means 996 times this variable has changed, either has gone up by 1 or has gone down by 1, okay? So that's that. So it's this first column is basically meaningless. Who cares about how many times this variable has changed? Okay, everyone is okay. What does total change means?
Yes.
Okay, so that's that. And then average time per change, meaning that between these changes, how long did it take? So by the time, for example, it went up by 1, okay, that's one change. And by the next time it was changed, either going up or down, how long did it take? And then by the next time that it was changed, either going up or down, how long did it change? Okay, so this is the time between those changes. And again, who cares that it just took 6 minutes between the changes of this variable, either going up or down, okay? The current value shows the value of this variable at the time we stopped the simulation. At hour 100, there were 24 parts in the system, okay? And again, that's just at that moment, at hour 100. Again, who cares?
Professor, so that coming back to your question, would then be the average? Because that gives us overall in the entire simulation time?
Okay.
Average value?
Average is the right number. So the three columns that may help you, or maybe, they will help you and they are informative, are minimum value, maximum value, and average value. But the one that is the most important and the one that definitely you have to report is the average value, okay? Remember when I was giving you the example, when I was giving you the example, I told you, okay, a new part comes to the system. So initially I'm 0. A new part comes to the system, it goes up to 1. Another part comes to the system, it goes up to 2. Another part comes, it goes up to 3. Another part goes up to 4. Before the 5th part comes into the system, one of these parts is done and is leaving the system. It goes down to 3 again. And then let's say a new part comes, it goes back to 4. A new part comes in, it goes up to 5. A new part comes in, it goes to 6. And then let's say before the next part comes in, another part is done and is leaving the system, goes back to 5. Another part is done and is leaving the system, goes back to 4. Another part is done and is leaving the system, goes back to 3. And then let's say another part comes in, 4, okay? So these are basically the value of the work in process variable in the system. If I could plot these over time, these are the values I would observe for this variable, okay? So average work in process reports the average of all these numbers. Maximum reports the maximum of these numbers, the maximum that we have observed at some point in the simulation. And minimum reports the minimum of these numbers, the minimum that we have observed at some point in the simulation. But the number, if your manager asks you, okay, what is the working process in this manufacturing plant? You are not going to report just one of this number. You are not going to report the maximum. You are not going to report the minimum. I mean, I wouldn't also report long list of numbers if you have, let's say, been able to collect data for, I don't know, a day, and you may have like 200 numbers. I won't report that long list. What I would definitely report is the average of these numbers. So I would say on average, work in process in this manufacturing facility is this number. I will also report the maximum, that's saying that at some point, we also had something around 38 numbers. Those are also good to know, okay? And then maybe also a time plot is helpful too. If you can plot these work in process variables over time, maybe that time plot can help you as well. If you see the numbers are not changing as much, for example here, okay, if you plot the time, if you develop the time plot, you may just see a number close to 4 going a little up and down. But if I see like, if I expect like suddenly crazy behaviors, I would also look at the time plot of these numbers just to make sure I don't see any crazy behavior. Suddenly it goes up and then goes down, or continuously it's increasing, things like that. But definitely, if given that fact, if you have this table available, the average is the number that you have to report. Okay, it's very, very important for you guys to know this, because I told you, you can be the best modeler and know all the techniques and so forth, but if you don't know what to report, it doesn't matter. If you go to this table and report total changes, and that doesn't have any value whatsoever, okay? So when you come to the variable summary, you have to know that the average is the one that you have to report. Okay, any question on working process?
Yeah, so regarding that average, how do we tie it to a time frame? So, for example, my manager comes to me and says, what's the work in progress? My question is going to be probably per hour, per shift, or what?
This is during the day. So this is for the 100 hours that we ran the simulation.
Okay.
If you want to report your work in process for a shift and your shift is 8 hours, then run it for 8 hours.
Okay, got it. Thank you.
Okay, but however, for work in process, especially for manufacturing facilities, because when we finish at the end of the day, in the next day, we start from wherever we left off the previous day, right? So you can just run the system continuously. If you run it for, if you want to run it for example, for the whole week, you can just run it for 40 hours. So let's say the week is 5 working days and each day is 8 hours. So you can just run it continuously for 40 hours. Okay? And that means like your whole week. And for the working process, actually, working process shows the average of what you have seen at any point of time. So even if you run it for 8 hours, the number may just change a little bit. If you run it actually longer, that number is more reliable. So even if it doesn't matter, it's like working process for a day or for a week, or because it shows the number of parts in your system at any point of time. Okay, so it's just basically, do you have these numbers for a week or do you have this for a day? But these are similar stream of numbers. You're just going to have them more and more and more. And if these numbers are more, the average is more reliable. So working process doesn't have the unit of time, meaning that working process for a day or a week. So I would report it I would run it for as long as I can and then report that.
Professor, I have a question. If I want to know the working process at a specific machine, do I use a similar syntax, or do I use a global variable as well, or is that a local variable?
So working process at a specific machine. So let's go to the location summary. Okay. You have here average content. Do you see that? Did you go to location summary?
Yes.
Okay. You have here average content, meaning that what is the average content of these machines during the simulation time? Okay. So for all of these machines had capacity of 1. Okay. That means their content, what are the possible values that their content can get? For Miller, for example, for the meal machine. What are the possible values that the meal machine can?
Right, so it would have a maximum of 1.
Yeah, it's either 0 or 1 because it has capacity of 1. At the very most, it can hold 1.
Okay.
If there's no part, then it is 0, right? So this number that you see is the average of 0, 1, but the reason that it's not 0.5 is that this is weighted average. It's also important for you guys to realize that part. So let's say, okay, let me give you a simple example. Let's assume I'm looking at the system and for just 10 minutes, and it's 0 in minute 1, 0, 0, 0, all the way 0 to minute 9, and then one part comes to the system, and then let's say at minute 10 that part also leaves. Okay, so I have looked at the working process in the system for 10 minutes. For 9 minutes of those 10 minutes, the working process has been 0. No part has come to the system. And just for the last minute, suddenly one part has come to the system. Working process has gone to 1. Okay. I ask you, calculate working process in this 10 minutes. What would you say? Calculate average of working process in this 10 minutes. What is your report?
Would it be 0.1 because you're taking the 1 divided by 10 minutes?
So the value of working process, if I look at the value of working process variables, so my working process variable, what are the possible values? Initially it's 0, and then it just stays 0, and then at some point, working process variable goes to 1 at minute 9, right? So the two possible values that my working process has received is 0 and 1. And like what we saw in that table summary for the variables, what is meaningful to report is average of work in process. Okay, so you want to report it to your boss. So you are going to report the average of work in process to your boss. So what is that average? The two possible values that you have seen is 0 and 1. What is the average?
0.5.
Okay, so 0.5. That's the number that you would report, right? However, if you look at this process and you know that out of these 10 minutes, 9 minutes it has been 0 and just 1 minute it has been 1. Do you think this average of 0.5, average work in process 0.5 is correct?
No.
What do you have to consider that you have not considered here?
They had more idle time. They had more zeros than you had one.
Exactly. So you have to consider the time factor here as well. So in the average working process that is reported, at the end, it's not just a simple average of 0 and 1. It's a weighted average of 0 and 1. And what is the weight factor? The weight factor is how long I observed 0 and how long I observed 1. So if you observe 0 for 9 minutes of those 10 minutes, 0 is going to get a higher weight in that weighted average. And if you observe 1 working process only for 1 minute out of that minute, 1 is going to get less weight in calculating the average. Okay? So at the end, the number is not 0.5, let's say it's 0.1, something like that. Okay, so your working process obviously is a number closer to 0. 0.5 is not the correct answer. Okay, so when the average of working process is calculated here for us, this average is calculated, the time for which we have observed any one of these numbers is taken into account in calculating the average. I don't want you guys are not going to calculate this by hand, so you just report it from here. But I want you guys to know the logic behind calculating these averages. Sometimes the averages that we report are just simple average. Add them up, divide them by the total number that you have observed. But in this example, the average working process that we observe here is a weighted average. And the weight that is used in calculating the average of these numbers is basically the time that the system has observed one part in the system, the time that we have observed 2 parts in the system, how long we have observed 3 parts in the system, and so forth. Okay? That's that.
You answered it, right? I mean, I think my question was just how do we correlate the...
And then, and that. Okay. And then for the quantity processed. Quantity processed, remember, shows number of parts that have been processed and have left the system. So obviously, again, total change. Remember here, remember total quantity process shows you how many parts have been processed and have left the system. Total change means number of times this variable has changed in the system. Every time, and remember, we change this variable every time we change this variable, every time a part left the system. Okay, so this means 486 times this variable has changed. And obviously, this is also equal to 486 total exits that we have, because this variable is changing every time when you observe a new exit. So that's why the total change equals to total exit. But again, never ever use the total change column. It's the most meaningless column that ProModel can report. If you want to know the total number of parts that have left the system, look at the maximum. Okay? So tell me, for the quantity process variable, which one of the columns makes sense? Again, current value shows the value at the time we stop the simulation. So again, we don't care. So the current value doesn't make sense. Average time per change shows the time between changes. Every time we increase it by 1, how long does it take till we increase it by 1 again? Again, no one cares about this column. So the ones that are meaningful are minimum, maximum, and average. Tell me which one of these columns are the one that you have to report. Which one of them makes sense?
It would be the average value, and then if you want to go ahead and report max and min values too. But
Tell
average,
me why average, Catherine.
because that's going to tell you that at any given point throughout the day or the time that you ran the simulation, this is how many parts you're going to have on average, as opposed to the other.
This is total part that have left the system, right? So how do we calculate this? Initially, no part has left the system, and then one part is leaving the system. And then another part is leaving the system. What is the value of variable of this variable? Catherine. So one part is leaving the system. The value of this variable is 1. Catherine. Another part is leaving the system. What is the value of this variable?
If this is this quantity processed or with?
Quantity process.
Okay, so this is going to be 1.
On one part has already left the system, so the value of this variable is 1. Another part is going to leave the system. What is the value of this variable?
It's going to go up to 2.
2, because we increase it by 1 every time a new part is leaving the system. Another part is leaving the system.
It's always going to be increasing by 1, so it'll be 3, and then 4, 5.
All the way to 448. 486. Okay? So if you want to report quantity processed, which is total number of parts that have been processed and have left the system, what would you report?
Your max value.
The max value. The average means basically nothing here.
Professor, is the average basically like what you have during half the simulation, like halfway into the simulation?
No, the average is just the average of these numbers. If you calculate, if you add all the numbers from 0 to 486 together and divide them by 487, which is the total of these numbers, that's the average that you see here. But it doesn't mean anything, because this variable is supposed to show you how many parts have left the system in that 100 hours. So what you have to look at is just the maximum value, the value at the very end. The average of these numbers doesn't show you anything. It doesn't say, what does average means? Like, I can't even make up a thing.
I would think that if there was like a steady output, then it would mean halfway into your simulation, that's how many you had.
But that's such a deterministic system.
Yeah,
Nobody
if it's
can develop
like,
a simulation. Okay, so it's important. Why I put these two together? Because it's important for you guys when you are looking at the variables. It's important to know which columns is the one that you have to report, which columns make sense and which column makes no sense. For working process, average makes the most sense. Maximum value is okay to report, but it's not a big deal. Average is the most important one. For quantity process, average means nothing. The maximum value is the one that you have to report. Okay, so pay attention. Understand the variable that you're reporting, and then find out which one of these columns are the ones that make more sense. Okay, and report that one. So if at some point in the future I ask you what is work in process and you report maximum value, then we have issue, guys. Okay. Any questions so far? Okay, make sure to save your model. And one more thing I want to mention before we close this model. If you go to your locations and, go to your variables and then click on work in process and then click somewhere in your simulation model. Something like this is up there. You see that, guys? Click on, click on quantity process, and then click on the simulation layout, and a window like this is up. Okay. So, and you can see the icons from no, they now are changed to yes, meaning that the icon of these variables are somewhere in the simulation model. Okay. Now, what does this mean? If you run the simulation, do you see that these two boxes shows the value for these random variables? For example, the first one shows the value of work in process. The last one shows the value of quantity each, and that's why it just increases by 1. However, the other one goes up and down. Okay. So if you define some variables and you just want to see how they are changing as you run the simulation model, that helps you to see how these variables are going up and down and if they make sense or not. So that's helpful. Okay. Did you guys add this too? And do you see it when you run your model?
Yeah, Professor, the counter just keeps going.
Okay. So now let's stop and go back to the layout, to the location. So now, if you have a bunch of variables, what you put here are a bunch of boxes, and what you see when you run the simulation is just these numbers in a bunch of boxes change. However, you want to know which one represents what, right? So in that scenario, we want to put like a text box or something next to them and just write down in that text box what is their name. So for that, okay, in 2018 version, you can go to insert text box and just click behind them, do a text, write down work in process, and then press OK. And then you can do similar thing. Go to the insert, click on the text box, and then click under the quantity process, and then press OK. Okay. That way, when you run, at least you know what shows what. For those of you who are doing the who are using the 2016 version, Emily, you are using 2016, right?
I think so.
Can you share your screen so I can show where you guys should go?
Sorry, I'm also using 2 computers, but let me try to mirror them.
It's okay, don't worry. Is there anyone else who is using 2016? Can you share your screen if your Zoom is on this computer so that I can show where you go?
I can share mine.
Go ahead. Okay. Can you go to the build? Background graphics at the very bottom. Front of grid. Okay. Can you also maximize your layouts? Yeah, just increase it a little bit. So, okay. Okay, so build graphics, background graphics, and then the front of the grid. And then if you go to the very, very left side, you see those red curves?
Oh, here. Okay.
Yeah, go to the top, go to the first one, there is letter A, you see? Okay, that's the text box. Click on that, click behind, yeah, here, just type work in process and press OK.
Right.
Okay.
Okay.
Yes, that's that.
Okay. Thank you.
Sure. Next, we want to develop another model. And this model is similar to the previous one. The difference is that after the grinder operation, we have an inspection going on. So what we are going to do for this one, guys, please open your previous model, save it as a new file in the folder for week 5. Save it as a new file. And then at the end of the name, put uncertainty in routing. So at the end of the name, you already had the variables, put the dash next to it, and just add uncertainty in routing. So that should be the name of your model, so that you know in that model you learn variables and uncertainty in routing. Okay, so open the model that we just developed, save it as a new file in the same folder for week 5. At the end of the name, put the dash and add uncertainty in routing, because that's what we are going to learn in this model. So this model is similar. Still forgings come to the receiving dock. They go to the miller operation and then they go to the grinder. But after the grinder, they don't go to the finished part store and then exit. They go through an inspection operation, which is done in a triangular distribution. The time for inspection has triangular distribution, average 6, max 12, and mode 8. However, after inspection, a couple of things happens. The parts either pass the inspection and just go to the finished part stores and are shipped to the customer. 73% of them go through this process. 5% of them just are marked as a scrap. 10% of them need grind rework. So they are the ones that have to go back to the grinders to go through the rework. And 12% of them need mill rework. So they have to go back to the mill operation to get the rework. Okay. So we want to see how to capture the inspection. Okay. For that, let's go back to the model that you just developed. Can I go to ProModel, or do you need this page, guys? Are you done taking the notes?
I'm ready.
Okay.
Go ahead, Professor.
Okay, so this is the inspection that we added, and put the capacity of 1 for the inspection. Okay, so let's see how we are going to do that. For when we want to add the inspection, obviously the parts that pass the inspection go through the finished part. But how about the parts that fail the inspection and they need to go through mill rework or grind rework or scrap rework or scrap and so forth? So there are a couple of ways to do that, but one way to capture this part of the inspection is that to create some virtual locations. For example, I create a location for, I call it mill rework, and let's assume this mill rework has capacity of infinity, meaning that every time a part is failing the inspection because of the mill rework, the part is just sent to that mill rework location, which is just a placeholder for these parts. And from that virtual place, they go to the miller to get the rework. Okay. Similarly for grind rework, I can create a virtual location that doesn't exist in the real world. So I can create a virtual location in the simulation with capacity of infinity. That location is going to receive all the parts that need grind rework, and then from there they can go to the grinder to get the rework. And similarly for the scrap, I can calculate a virtual location for scrap, and when the part needs a scrap, it goes to the scrap location, and then from there it leaves the system. Okay, so that usually helps us to capture these parts of an inspection process. Okay, so if you are dealing with inspection, and these are when you have some potential routes for the inspection, you can use this virtual location concepts to capture those. So let's go back to the location and create 3 more locations, 1 for mill rework, 1 for grind rework, and 1 for scrap. Okay, and let's put capacity of all of them as infinity. I'll explain in a little bit why. Okay. So let's go back to the location and just create 3 locations for and save. Okay, everyone is good so far with the locations? We have a new location for inspection with capacity of 1. We added also 3 more. We call it virtual locations because they are not really in the manufacturing process, but we call them as mill rework, grind rework, and scrap. And we also have the finished parts store that we had from the past. Make sure the rework or locations and the scrap have capacity of infinity. The inspection has capacity of 1. Everyone is done?
Yes, ready.
Almost.
Okay. We don't change the entity. We don't change the arrival. We are going to change the processing. Okay. So let's go to the processing. So I would say, just for the sake of simplicity, let's just click on the very last row and just delete that record. We'll add that later. So that just makes it easier to add everything else. We don't need to have to necessarily, but just it makes it easy. Okay, so delete the very, very last row in the processing. And then we are going to add the inspection part. Make sure to save before we go forward. Guys, are you done? I want us to do the processing together. Are you done?
Yes.
Anyone needs more time? Okay. Okay, so let's go to the processing, the very, very last line. We deleted the 4th line. So in the 3rd line, after a part is done at the grinder, where do they go?
Inspection.
Inspection. Okay. They go to the inspection. Next line. Where am I right now?
Inspection.
Inspection. Forging. And okay, so after the inspection, remember, we can have 4 possible destinations. Okay, so I'm going to list all of them. So the forging can go to mill rework. The forging can go to grind rework. The forging can be scrap, or they can pass the inspection and go to finished parts store. Okay, so we added 4 lines in the output sections of inspection. Make sure you don't create new blocks. It's just 1 block. We talked about that in previous session. So the new lines that we add are just part of 1 block. Make sure your new lines do not have their own block number, 2, 3, 4. Okay. Then we want to tell the simulation that, for example, 10% of the part goes to mill rework. So what is the percentages? 12% go to mill rework, 10%, 5%, 73%. Okay. Okay. So for that, let's go to rule. Click for the first line. Click on the first line, mill rework, and then click on the rule. And then here you see the probabilities. Click on the probability. This box is activated. So on that is 0.20. Okay, so that's 12%. And then for the grind rework is 10%. For the scrap is 5%, and for finished parts store is 73. And then press OK.
Also, Professor, I had a mistake, so I'm trying to catch up. What was the first one rule for mill work destination? It was 0.12, right?
Yeah, it's here.
Okay.
So on the rule, click on the probability and then enter 0.12.
Okay.
0.12, 0.1, 0.05, 0.73. Make sure to save. Okay, done, guys. Let's go to the next line. So let's assume we end up at mill rework. Working, we end up at mill rework. Where do we go from there? From mill rework means that the part
exit.
You go to milling.
Back to Miller.
Back to mill.
Back to mill to get the rework. So these are the parts that need the mill rework, but they haven't gone through the rework yet. We just put them in a container. These are the parts that need mill rework, a container with capacity of infinity, but they haven't received the rework yet. Okay, so then from mill rework, they go through the mill operation one more time. And then after that, they go through the rest of the operation. Okay, so the parts go through the ones that need mill rework, go through the mill operation, and then they go through the rest of the operation again. And if they pass this inspection this time, they leave. Otherwise, they go back to the system again. Okay. How about, okay, so before we go, for the inspection time, guys, what was the inspection time? Wait.
Triangular 6, 8, 12.
Yeah. Okay. Just make sure to add the inspection time too. Okay, so mill rework, they go to the mill rework and from there they are sent to the mill. Do I need to tell the simulation where do they go from the mill?
No.
No.
Because
Professor is 12.
What did you say? Oh, it's 12, right? Yeah, sorry. Okay, thank you. So simulation knows already where do they go from the mill, so we don't need to repeat that again. Let's assume they end up at grind rework. Where do they go from there? They need grind rework. So I put them just in a box. I call it grind rework holder. Where do they go from there?
Grinder.
They go to the grinder to get the operation. And then from there, they go through the rest of the process. Next, let's assume a part ends up at scrap box. Where do they go from there?
Exit.
Exit. And let's assume they pass the inspection and they go to finished part store. Where do they go from there?
Exit.
Exit. Make sure to save, guys. Okay. So at inspection, we have 4 possible routes. That's why we call it uncertainty in routing, because we don't know exactly where an entity will end up. Simulation is going to generate random numbers between 0 and 1 behind the scene. And for each entity, it's going to tell the entity where to go. And if the entity ends up at any one of these locations, we just send them to the right destination. One more time, the grind rework and mill rework and the scrap that we put, they are just some virtual locations just to keep these entities. And then just to hold them, like a pallet that holds all the parts that need mill rework, another pallet holds all the parts that need grind rework, another pallet holds all the parts that are scrapped. But doesn't mean that when they have gotten to these locations, the rework has already been done on them. They are just we put them in those rework places, and from there they go to the machines that need to perform the rework operation on them, either mill machine or grinder machine. Okay. And
Professor?
Go ahead.
From forging and scrap, where does it go to exit? I missed that part. Okay, just want to make sure. Thank you.
Yeah. And I put capacity of infinity for these rework operations, rework holders, because I don't want them to block anything. So these are just some placeholders, right? If inspection guys inspect a part and the part needs rework, the guy is not going to keep it in his hand till the rework guy, till the grinder guy or the mill guy is idle. The guy is going to just leave it somewhere, and then the grind machine or the mill machine, they will pick up that part that needs the rework whenever they are done. Okay, so that's why I put capacity of infinity for these rework operations, such that whenever a part fails the inspection, they just go and wait in these rework operations, and they don't block anything. And whenever the guy on the grinder or mill is idle, they are going to pick these parts from the mill rework or grind rework to process them. So it's important to keep these as capacity of infinity.
Professor, instead of virtual location, can we use queues for 3 queues?
You can, those are still, you can use queues. Still, I call them virtual because, you can use anything. The only thing with the queue, just pay attention if the order, if the queuing first in, first out, or there's no queuing. So just keep that in mind.
Okay, got it.
As long as we create a location with capacity of infinity, that's fine. So I'm going to ask you one question. I could, from inspection, instead of just sending them to the mill rework or grind rework, I could just say, go to the mill. I could just say here, go to the mill, or go to the grinder directly. So I don't have to send them to this mill rework holder or grinder holder. I can just send them to the mill or to the grinder directly. Tell me why I don't do that.
In the meantime, they will hold the parts in the inspection. They will wait till the miller or the grinder gets free, then they will pass it to the miller or grinder.
That's correct. So if I just do that, if I just say from inspection, directly go to the miller or grinder, and if this guy is busy with the part and this guy is also busy with the part, what the inspection guy is going to do, he doesn't have any place to leave this part. He's going to just keep this part in his hand till finally this guy, for example, is idle and is going to send the part to this guy to do the rework. Okay? In other words, the inspection machine is blocked by that part, which is done. We have finished the inspection, but we can't just leave it somewhere. We just have to wait till these guys are idle. And that doesn't make sense. That's why we put this miller rework and grind rework just as a placeholder. Whenever this guy at the inspection is done, instead of keeping the part at his hand, he's going to just leave them at the mill rework queue and at the grind rework queue, and is going to start working on another part, and these parts will stay there, and whenever the grinder guy or the mill guys are idle, they are going to pick these parts from the rework queue or from grind rework queue or mill rework queue, and they are going to process them. So because of that, it's better to send this to mill rework. So so basically my point is that if you put mill or grinder instead of mill rework or grinder rework, you don't get error in the simulation because it's correct, but intuitively it doesn't make sense. So you just get numbers that are just crazy. So that's why we put this grind rework or mill rework locations so that we put the parts that got inspected into them, and then later they go to get the rework whenever these guys arrive. Make sure to save.
Professor, can you help me? Can you walk me through how you put the probability, the percentages into the rules? Because I can't get that box.
Click on the rework, for example, click on the rule, and then probability so that this box is activated.
Okay, and then where do you put in the number of probability?
Inside the box.
Okay, thank you. Got it, thank you.
Sure. Okay, and then we want to write this model for 100 hours.
Quick question, Professor. Are we still doing a move logic for all processes?
That is true. It doesn't matter, but let's just, for the sake of getting similar numbers, let's put that. So from inspection, wherever we want to go, let's put the move for 1 minute. So from inspection, if you want to go to mill rework, so I would put it here for the mill rework. But then from the rework to the mill and from the grind rework to the mill, I wouldn't put it. Why? Logically.
Because those are only the pallets that we are sending from inspection to miller or grinder.
Yeah, so basically, if you look at the real world, from inspection, I want to send it to the guy to get the mill rework, right? So if I put 1 minute for mill rework and 1 minute from mill rework to the mill, that doesn't make sense, as if it's 2 minutes. But however, if there is the distance between the inspection and the mill guy is just 1 minute, so I just need to put 1 minute, either put it from inspection to mill rework or from mill rework to mill. So just one of them, not both of them. Does that make sense? So that we just capture 1 minute of move time going from inspection to the mill machine, going from inspection to the grinder. I just want this to be 1 minute. If I put 1 minute from inspection to the mill and then 1 minute from mill to the mill rework to the mill, that's 2 minutes. So just put 1 minute on one of these transitions.
Another thing, Professor, is how would we go about editing the work in progress and the produced quantity?
And okay, that's the question I have for you guys. So for work in process, when the part came to the system, we added the work in process by 1. We increased it by 1. Now, with all these changes, where should I decrease it by 1?
At the finished part store.
2 places where
Scrap.
Okay, you are talking together, so one person at a time.
There should be WIP equals WIP
Where?
minus 1 at scrap and WIP equals WIP minus 1 at finished part store.
Why both?
Because the part is leaving the system in both places.
Okay. So at the finished part store, obviously they leave the system. We put 1 over there. And also at the scrap line, we also put 1 because when they are scrapped, they also leave the system right there. So we put 1 over there as well. How about total quantity? Quantity process. How about quantity process? I want to see how many parts are done and are leaving the system. Where should I increase that variable?
it should be on only on the finished product.
On the very last line, increase quantity process. So just use both ways that we write code just for the sake of practice. Everyone is done?
Yes, done.
Yes.
Okay. Now, before we run, I want to ask you guys to calculate how many parts went through the rework, how many parts need rework, how many parts need mill rework, how many parts need grind rework, and how many parts got scrapped. Calculate those for me. So define variables and tell me how many parts need mill rework, how many parts need grind rework, and how many parts got scrapped.
Yes.
Can you tell me where do you add the variables that calculates number of parts that need mill rework?
I would put. I was working on adding the something else on it. I would put mill return is equal to mill return minus 1, or do I have to add it?
Where?
On mill return, on mill rework.
So in this line?
Yeah, but we have to add our variables. So I want to make sure that you have.
So you say mill?
Yes, and then you could put decrease. You could put decrease instead of is faster.
So like this?
Mm-hmm.
Okay, so what is, when you create this variable, when you created this variable?
Yes.
What is the initial value?
Oh, no, so we have to add it then.
Answer my question.
Oh, what is that value?
What is the initial value?
You're adding to it. It's basically
what is the initial value, girl?
It's
what is the initial value of this variable?
It's because it was not part of the process, so we went back to the mill.
I don't ask if you add or deduct it. When you create the mill rework variable, what is the very first value that this variable has?
It's an integer. I don't know what you're trying to get from me.
When it's empty?
No. I said when we create any variable, the very, very initial value is always 0.
Yes. Sorry.
Always. When you create a variable, always, the very, very initial value is 0. So the very, very initial value of mill rework variable is 0. So now.
So it should be adding.
Okay, let me ask you this question. So we go here. The very first part goes through inspection and goes through mill rework, meaning the part needs mill rework. Now we go here. So the simulation goes through this line. What you said is that get the mill rework variable, whatever it is, which is 0, minus 1, and save it in the variable. So minus 0 minus 1 is minus 1, and minus 1 will be saved in the variable. And then, okay.
Yeah, I understand now. Sorry. Yeah, it's supposed to be adding 1. So whenever it enters that mill rework, we add 1. So we have to count how many times it enters this.
Tell me how about the scrap? How do you count number of parts that got scrapped?
The same way.
What do you add?
So we press enter on our operation, and then we get increase, and scrap, total scrap.
And grind rework?
Same way. Increase and scrap. I mean grind rework.
That's it. Everyone is good so far?
Yes, Professor.
Okay. Make sure to save and then press simulate. Let's go. Do you get similar numbers? Let's go to variable summary.
Yes, Professor, we have similar numbers.
Okay. For Miller rework variable, which is reporting all the parts that need Miller rework, mill rework, which columns you have to, which column is the one that you have to report?
Total changes?
Total changes?
Yes. 57.
Just as we were going through the results of previous model, I said, never, ever look at total changes column. Never. Total changes and average time per change are meaningless. Never, ever look at this. So which column is the one that we have to report for total number of parts that need mill rework?
Maximum.
Maximum.
Maximum. Okay, because this is a variable that we increase by 1 every time a part goes to the mill rework location. So we have to report the maximum. Do we have to report the average?
No, Professor.
Does not make sense at all. It's meaningless for these type of variables. How about grind rework? Total number of parts that need grind rework. What column is the right one to report?
It should be maximum.
Maximum, because we increase this variable by 1 every time a part needs rework. So the maximum, which is the final number, is the one that we have to report. So obviously the maximum is also the current number as well, because that's the final value when we stop the simulation. But I don't want you guys to pick these numbers from the current value or from total changes, because yes, for these specific variables, they are the same, but generally the answer to my question is picked from the right, should be picked from the right columns, not these ones. So that's why I say never look at total changes, never look at average time per changes, never look at the current value. Always the answer is in one of these other columns. How about the total scrap? How many parts got scrapped?
It's 34 in the maximum value.
34 in the maximum value. Okay, the average makes no sense for these three variables. The only variable here that for which the average is the right number to report is work in process. Any question?
Professor, sorry, I have a small question. I know it doesn't make a big difference, but I have a question regarding the variables on your ProModel software.
Go ahead.
If you can click on the variables on your screen, the icon, the first two for me says no. Do you know how to change it to yes?
Just click on the variable and then click here. And then it's changed to yes.
Okay, sorry, could you repeat that one more time? Sorry.
So here, the say grind rework has no.
Yeah.
Right? Click just on this variable and click on the layout.
Oh, okay.
Icon is yes, meaning that the icon of this variable is shown here. Click on any variable.
I see.
Click on the layout. The icon will be shown here. The only thing that you need to do is to go to insert and put the text box next to each one of them and write down what that variable is.
I see. Okay.
Otherwise, there are just a bunch of boxes.
Yeah. Okay.
Thank you. So I had a question.
Go ahead.
Are these three new variables that we added are local variables for any reason?
You got disconnected.
Because previously you mentioned about two different variables, one global and second local.
Global and local. Yeah, everything we define today is global.
Okay.
We haven't learned the local variables yet.
Okay.
Everything you define using this variable menu window, everything you define using this variable menu,
Yes.
is a global variable.
Okay.
And we learn local variables later.
Okay.
Can you stop sharing?
Oh yeah. Thank you.
Yeah.
I think I'll be able to.
See if running that changes the number. So guys, what I want you to do is to save and close your model. Any question first of all left on how to capture the uncertainty in routing? So the probability option on the rule is the one that is going to help us. And when we have the inspection operations, it's always helpful to add these virtual locations for holding the parts that need the rework. Otherwise, if we just send them directly to the machines that are going to perform the rework, it may cause a lot of blocking for the inspection machine. So that's that. And then you also did the variables yourself, so you know how to add the variables, where to add the variables to count, and what to report from those variables. So make sure to save, guys. And I want us to start the new model, and hopefully we can finish it. We'll see how far we can go. So this time we are going to start a new model. So create a new file in your folder for week 5. And we are going to name this file as error composite. And what we are going to learn is temporary batching. Okay, temporary batching. And so create a new file in the folder for week 5. Name your file as error composite - temporary batching. That's the temporary batching is the rule we are going to learn. I'll tell you in a second what does that mean. So here in this model, we have an order queue, so the entities that are parts arrive to the order queue. From there, they go to ply cutting or ply cutting, I don't know. And the processing time on this machine is uniform, 30 minutes, 5 with half bit of 5. They go from there to the layup machine. The processing time is uniform, 40 minutes. From there, they go to the autoclave. The processing time at autoclave is 90 minutes on average. And then they go from there to the ship queue that has capacity of infinity. And then from there, they go to the ship clerk. And then they leave the system. And the ship clerk takes on average 15 minutes to get the part ready, or they get the order ready and ship it to the customer. So what we wanna, what is the specific thing about this model is that when the parts get to the autoclave, in autoclave, we process 5 parts together. So the parts go through the process one by one. But when they get to the autoclave, we don't process one on autoclave. We have to wait till we have 5 parts, then we process that 5 parts all together. And then they go through the rest of the process one by one again. Okay, so just at autoclave, we are going to have a group of 5, process them, and then they go through the rest of the process one by one again. Okay. And why this happens usually, a lot of the times it happens in the processes that we have a process that is very time consuming, like here, it takes 90 minutes. Or sometimes the processes are just too expensive. And in those machines or those processes, we may have the option to process a couple of parts together. So if I can use this 90 minutes to process 5 parts together, then I do that so that at least after this long time, I have more parts going through the rest of the process. So the parts arrive to the system every 90 minutes on average, exponentially distributed. And that's it. So pretty much if you were going to just develop the simulation model and forget about that autoclave processes 5 parts together, you could just do it easily, simply. We have 2, 4, 6 locations. All of them have capacity of 1 except the order queue and the ship queue. These 2 queue have capacity of infinity. And we have 1 entity, parts, that is coming to the system. Parts arrive every 90 minutes on average, exponentially distributed. So that would be an easy model that you can develop very fast. The only thing we want to add is this part, autoclave. So,
Professor,
go ahead.
Does that say process 10 parts together above the autoclave?
Let me check. Yeah, it processes 10 parts together. My bad. So I look at this. So the capacity of autoclave should be 10. Forget about this 5. The parts, it processes 10 parts together, and the capacity of autoclave should be 10. Thank you for noting that. So guys, create the locations very fast. Create the entity, create the arrival. We do the processes together. Okay. So you have these locations. The queues have capacity of infinity. The oven has capacity of 10. For the queues here, I don't have any queuing rule, but if you have it, it's okay. For just sake of similarity of numbers, just change it to no queuing if you have a queuing rule, but it doesn't matter in reality, just fine. Okay, everyone is okay with the locations?
Yep.
And then we created one, oops. Entity parts. Okay. So I'm going to call the entity raw material. So, or I'm going to call it parts. Okay, so for now, just we need 1 entity. So you guys need to create 1 entity, and that's parts. Okay. And this is the arrival. Parts go to order queue 1 at a time, and the frequency is E60. Occurrence is infinity. Okay. So now let's go to the processing.
I thought we had E90 for our arrival time.
Yeah.
So E90. Go to the processing. So what is the first process? What is the first line of our processes? Parts go from
order queue to the
order queue to the cutting machine. Second line.
From ply cutting to the layup.
Okay. So the first line, the parts go from order queue to the ply cutting. Let's assume the move time between these 2 machines is 15 minutes to add that part too. Then the parts go from the cutting machine to layup, and that move time is also 15 minutes. Is the processing time 35? Okay. And then parts go from the layup to the oven, and the processing time at layup is uniform 40 minutes, and that move time is 15 minutes as well. Okay, everyone has these 3 lines so far? So the parts go from order queue to the cutting machine, then from the pre-cutting to layup, and then from layup to oven, and you put the processing times on the cutting machine and layup as well. And all of these transitions have 15 minutes move time. Everyone is good so far?
Yes, Professor.
Okay. So now, next is now where are we?
Now at oven.
Oven. Okay. Right now at oven, so click on it so that the operation window opens. Let's write it here. So, okay, what we want to do is called batching. What does that mean? Let me explain here. So what we want to do right now is called batching. What is batching? In simulation, whenever we want to group a couple of entities that are similar together and process them together is called batching. In this example, we want to group 5 entities, 5 parts that are similar, and then process them together is called batching. Okay? If in the packing operation, so let's say we have tea bags, and then we want to pack, let's say 20 tea bags in one box. So these tea bags are the ones that go through the process one by one, and then we want to just group them, 20 of them, and put them in a box. That's batching. Okay, so whenever we have our entity and then we want to group a specific number of the same entity and then process them together, do something on them together is called batching. Now, the batching has 2 types. The batching has 2 types. One is called temporary. Okay. One is called permanent. What is temporary batching? When we bring a couple of entities that are similar together, we process them together, and then they go through the rest of the process again one by one. That's called temporary batching, meaning for some limited amount of time, we bring them together, we process them together, we do something, but they go through the rest of the process one by one. What we want to do right now is temporary batching, because we want to get 10 of these parts. We want to process them at autoclave together, but they go through the rest of the process again one by one. So since we bring 10 parts that are similar together, that's batching. And since after autoclave operation, they go through the rest of the process one by one, that's temporary batching. Okay. What is permanent batching? Permanent batching is the scenario when we bring similar entities together. We perform some operations, but then for the rest of the process, they go together as well. For example, for the tea bag packing, I told you, is permanent batching. We process these tea bags one by one, then we put 20 of them together in one box, and for the rest of the process, this box of tea bags go together. There's just a box that's going through the rest of the process. So the tea bags, the 20 tea bags that came together to go through the rest of the process together. So that's called a permanent batching. Okay, so what we want to learn right now is temporary batching. That's why I asked you guys to put the temporary batching at the end of the name of your model so that you know what you learn in this one. Any questions on what these 2 terms mean? Temporary batching or permanent batching?
So just to clarify, the temporary would be, they're going to be batched for a moment in time, and then when they leave the system, they leave as single units, as opposed to permanent, they leave the system as one complete batch?
No, it's not that leaving the system. They come together for some amount of time, they get processed together, but then they go through the rest of the process one by one. Like this time, autoclave. And the parts go through the process one by one. Okay? And then when they get to the autoclave, we don't want to process them one by one. We want to wait till we have 5 of them. When we have 5 of them, we have 10 of them. When we have 10 of them, then we process all these 10 together. And after we are done processing them at autoclave, all these 10 together, they go through the rest of the process again one by one. They go through the queue one by one. They go through the shipping clerk one by one, and they leave the system one by one. Okay, so these 10 are together just here at these operations. That's why it's called temporary batching. But for permanent, if it was permanent batching, at this point, yeah, they come together. We process all these 10 parts together, and then they go through the rest of the process as a pack of 10. And then finally leave the system as a pack of 10.
Okay, thank you.
That's permanent batching. Sure. So now how we write that? So in the oven, so the command for that is group
10
as
batch.
Okay, so what do we wanna, okay, so now I wanna call this group something, okay? So when I put 10 of them together, I wanna call them something. So that becomes a new entity in my system. So let's assume I wanna call this entity as batch or anything you want, but I have to create a new entity because now as if I'm creating a new entity, which is just these 10 parts together. So let's go back to the entity and create a new entity. I already have done it. Create a new entity, call it batch. Okay, so you already have only one entity, that's parts. Just add a new entity, any icon you want, call it batch. Or anything, the name doesn't matter. Call anything you want for this batch of 10, okay? When you are done, let's go back to the processing and then finish our comment. So group 10, because we want to bring 10 of them together as, we are going to name this group of 10 as batch. When I type a B, just the name of the second entity comes up. Group 10 as batch, okay? We don't put anything on the destination part. Just write that one line. So everyone is good so far? So next.
Professor, what about processing time?
So we will do that in a second. Okay. So let's go to the next line. So now, what is the entity that I have right now?
Your batch?
It's batch. I don't have parts anymore. I have grouped them as batch. And where I am right now?
Autoclave.
Oven still.
Oven or autoclave, sorry. And then here, I'm going to process this batch of 10. So what is the processing time?
Uniform 9010.
Okay. So I'll keep that. And we are going to add one more line. After we are done with the processing, we are going to say ungroup. So that's the keyword. So basically we are going to group first to create this new entity, group 10, group 20, as many as you know what happens in your system. Create this new entity, nothing in the destination. Next line. Now this new entity at oven is going to be processed. We put the processing time and then we ungroup, meaning that after the processing time is done, we ungroup them so that they go through the rest of the process one by one. Again, nothing on the destination side. So for 2 lines, I have nothing on the destination side. In the next line, what is the entity I have?
Batch. Oh no,
Parts again.
I don't have batch anymore. I just ungrouped them.
No, I said parts.
Parts, I'm sorry. So parts, where are they?
Autoclave.
Your autoclave, my oven. And where am I going?
To the
shipping
queue. Chip queue.
And the rest is easy. Parts from ship queue to ship clerk, and then from ship clerk to exit. And at ship clerk, the processing time is normal. That's that. Okay. I want you guys to also calculate work in process here. How do you do that?
Put a variable and write that down.
Go to variable, define a new variable, call it work in process, WIP, or anything you want.
And then from there you input the increase work in progress at the first line.
Okay, when they get, as soon as they get to the order queue, we increase work in process. That's correct. Then?
And then you put down the decrease work in progress at when they're about to leave the system on the last location.
And then? And then here, guys, you saw at the autoclave or oven, we process 10 parts together. That's why I put the capacity 10. At the very least, it has to be 10. In the book, it has put capacity of infinity, so that's fine too. But obviously, our numbers is different if you put capacity of infinity. But if you put capacity of 1 or 2 or 5 or anything less than 10, you get error. Since we process 10 parts together at oven, it should be at the very least 10. Let's run this for 1,000 hours. Okay. And then if we go to work in process, what do you report for work in process in this process?
Your average value.
Which one?
Average.
Average. For work in process, you always report average. So on average, we have 8 parts being processed somewhere. And at some point, we also have had 18 parts in this. So this, you have to remember these rules. I mean, obviously for the exam and things, you can have notes, but you have to know how these are, because if you don't know them exactly, then in the exam, you sometimes forget, you put something in the destination side, you forget on group and things, and you get a bunch of errors, and then before you know, the exam time is over. And we are going to learn these rules like 2 or 3 every session. So the number of these rules are going to just increase significantly. So make sure you learn each one of them very well, and you are comfortable with that before we move forward to the next one. I don't want to hold you guys any longer. Is there any question?
Were we supposed to add a move logic to the oven to ship queue and ship queue to ship clerk?
It doesn't matter. You can or you can. I mean, if you add it, then it affects your results. If you don't, it doesn't.
Okay.
I mean, they're not that's what I mean is that the point of this model is the group on group for temporary batching. Any question, guys? Okay, save your model. And I'll post the homework for this week, which has practice problems related to these three models, related to whatever we learned today. If the homework have something that you guys haven't learned to do, feel free to email me and then I can explain. If you can do it, I'll explain. If I know it's something that you guys can't do it yet, I'll email everyone. If there's no question, I see you guys next week.
All right. Thank you, Professor.
Professor.
Good night.
Good night.
Dr.
Thank you,
Falafini.
Professor.
Thank you.
Bye-bye.